Good day, everyone. Welcome to another series of Chemistry Just Got Easier with DR Tutors. In today's class, we are going to be having fun with the reactivity series of electrode errors. What is a reactivity series? The reactivity series is a chart that shows the arrangement of metals in order of their decreasing reactivity. In the reactivity series, the metal squad, you can see them here, they are arranged here. You have the highly reactive metals, that is, they are the metals that give electrons easily, like your lithium, your potassium, your barium, your calcium, your sodium, your magnesium. You have your moderately reactive metals, such as aluminum, zinc, iron, tin, lead, and you have your less reactive metals. They hold on to electrons, they don't let it go. They said they won't let it go, like your copper, your silver, your gold. So the reactivity series simply shows the arrangement of metals in order of their reactivity. You can see when we go from the left to the right here, reactivity reduces, and when we go from the right to the left, reactivity increases. And one thing to also note is that highly reactive metals such as sodium, potassium, and aluminum, they are too reactive to be reduced by carbon. Moderately reactive metals are extracted by reduction with carbon in a blast furnace. Less reactive metals are found in their naturally pure state. They hold on to electrons, remember. Let's talk about a treasure hunt, which is the reactivity series and metal extractions. Let's think about metals as students that have different personalities. Highly reactive metals, as we have said, sodium, potassium, and aluminum, are the super energetic students. They are filled with energy. They hold on to their compounds so tightly that carbon can't separate them. Due to this, the only way to free these metals is through electrolysis, using electricity as a powerful metal rescuer. For example, sodium chloride. When you actually pass electricity through molten sodium chloride, you have pure sodium metal will be deposited at the cathode. We also have the moderately reactive metals such as iron, zinc. They are not as stubborn as the highly reactive metals. Carbon can convince them to let go of oxygen through a process called reduction in a blast furnace. For example, let's see for iron. You can see here carbon was able to convince iron to let go of oxygen. Then you have iron trioxide reduced to iron in the blast furnace, and you have the release of carbon dioxide. You see, here carbon monoxide acts like a thief, stealing oxygen and leaving behind pure iron, Fe. Cool, good job. Then we also have the unreactive metals such as the gold, the silver. They are actually the easiest to obtain because they are so unreactive that nature often leaves them in their native pure form. Imagine finding a gold nugget in the ground, no extraction needed, you just have to pick it up. So the easy rule to remember is that the more reactive the metal, the harder it is to extract. Very reactive, you use electrolysis. When you have moderately reactive metals, you reduce them with carbon in order to extract them. And unreactive metals, you find them pure in nature. What is the memory trick? The stubborn metals need electricity, the cooperative metals need carbon to convince them, and the lazy metals are already free. Thank you for listening. Don't forget to book a session with us for your summer class. Bye. See you in the next class.